Hi, welcome to SAP Business Objects 4.0 training program. So in this training program, we'll be discussing about multiple tools that are involved in Business Objects Enterprise. And those tools are first we start with data warehousing introduction, which is prerequisite to learn business objects. So in this, we'll be covering about what is OLTP and what is OLAP, and the types of OLAP systems, and what are all the tools involved to build a data warehouse solution. And we'll also look into the basic SQL like joins, cardinalities, views, or datetime functions, which we'll be using while building reports using business objects reporting tools. So once we are done with basic introduction of data warehousing, we'll be discussing about architectural overview of business objects enterprise, and wherein in this architecture we'll be discussing about each and every layer, how they are integrated in business objects, and each and every request that we provide from the client tools, how it's going to receive and how it's going to process our request in business objects. And we'll also learn about universe design tool, which is also known as semantic layer, that lies in between the database and the reporting tool, which we use this designer to build runtime cubes. And we'll also define the relationship between the tables that are required to build the reports. And then we have a new tool introduced in the latest version, which is Business Objects Enterprise 4.0, that is Information Design Tool IDT, which is again a semantic layer, which is similar to universe design but with some more advanced options that we have. And going forward, we'll be dealing with this new semantic layer in business objects reporting, which is IDT, Information Design Tool. And then we have a reporting tool, which is Web Intelligence or Web Intelligence Rich Client. We have two versions, one is client based, the other one is web based. So Web Intelligence is a web based application wherein we can generate the reports through browser. And we have another tool, which is Web Intelligence Rich Client, which is a client based tool which needs an installation on our machine to generate new reports. So we look into a standard steps, how to create web reporting tool, and how do we create variables, and how to format the report. And then we also have another reporting tool which is known as Crystal Reports Designer 2011, which is the latest version in the market. And this is also known as Pixel Perfect Formatting Reporting Tool, and this is usually used to generate reports on operational data stores. So we'll also discuss about the steps involved in generating crystal reports, and also how to create formulas and how to format the reports. And then we have another designer, which is Dashboard Design Tool, which is also known as an Excelsius designer. Now in the latest version it was renamed as Dashboard Design Tool, which is used to generate graphs in the form of a flash file, and we can also export the output to in the form of HTML file, which is also known as lightweight reporting, which deals with summarized level data. And followed by we have a query as web service, wherein we can publish the queries, SQL queries that we have generated on top of semantic layers as a web service, and we can use that web service to consume the data from business object server machine to any other third-party tools. So that is about query as a web service. And we also have widgets, which is going to act like a web content, or a wherein we can place specific content of Web Intelligence reporting tool on top of our desktop, and we can closely watch the changes. And then we'll also discuss about live office reporting, which is an integration between MS Office tools and business objects. And again we have import wizard and publishing wizard. So these wizards are client-based tools which is used to migrate the content from one business object server to the other business object server. And then we deal with Voyager, which is a web-based application which can directly connect to the backend database cubes, and we can generate the analysis reports. And we'll also discuss about administration part of business objects, which is how to secure the application and how do we schedule the reports and publish the reports in a centralized server, which is known as business objects enterprise system. And the last one, which is a security implementation. Once we develop all the reports and publish it into a centralized location, then we start applying a security on each and every folder for each and every user and user groups that we have in business objects. So this is an overview of the course content which we are going to discuss in Business Objects 4.0 training program. Thank you. Hi, welcome to Business Objects 4.0 training program session. So as part of this training, today we'll discuss about Introduction to Data Warehouse, which is prerequisite to know from where we get the data before we generate any reports using Business Objects tool. So what is a data warehouse? Let's see. So a data warehouse is a predefined solution which we are going to build for our own analysis purpose. So in order to briefly define the data warehouse, I have some scenarios explained here. So let's look into this first scenario, wherein ABC Private Limited is a company with branches at multiple locations like New York, Chicago, Atlanta, and Austin. So now, from all these branches, the sales manager wants a quarterly sales report to see how the sales were populated for each and every location. And that report should consist of all the city's information, wherein this particular ABC Private Limited company has multiple branches in multiple locations. Now in this scenario, we have a different database at each and every branch. For example, New York, I'm using a SQL Server as a database to store the sales information, and then in Chicago, I'm using Access database, Atlanta, Teradata, and Austin, DB2. Now in each and every brand they have their own database, and they have the sales information stored in multiple databases. Now the sales manager wants to see a report, and the report, it should be something like this: sales per item type per branch for first quarter, which means for a specific item I want to know the demand in all these branches. So how many items were sold in each and every location? Based on that, I can come to a conclusion that in a specific location I have a huge demand for this item, and I need to order more items where I have the huge demand to generate my revenue. So in this scenario, in order to build this type of a report, first thing is we need to have all the tables connectivity, and the report should be able to connect to multiple databases. So what is the issue here that we have to generate the report? One is we should have all the connectivities from a centralized server where you're building the report, and from that server you should be able to connect to these multiple databases which are remotely located. And then since we are connecting to multiple databases and fetching the data, so there might be a performance issue. So remote connection and the performance, these two are the problems that we have, and if any one of the connection is down, we won't be able to run the report. So how do we overcome this type of problem when we generate the report connecting to multiple databases located in multiple branches? So to overcome that, so we have a solution here, like extracting the sales information from each database of each branch and store that information in a common repository at a single site. So if we have all this information in a centralized repository in a single location, then it would be easier for me to generate a report on all the branches data. So how do we build that? So that's where we go for a data warehouse solution, and wherein from multiple heterogeneous databases we extract the information and we store that information in a centralized location, which we call that as data warehouse, which is again a database. It might be SQL Server or Oracle or any other database, but this time I'm going to store this information in a centralized database at a single location. And how we extract the information from multiple databases which are remotely located? We have different ETL tools, extract, transform, and loading tools like Informatica, SAP BW, Data Stage, SAP BODS. So these are all some of the ETL tools that are available in the market to extract source content and load it into the target database. So we use those ETL tools to extract the content from multiple remote location databases and load that information in a centralized database. And now we use this centralized database as a source for our reporting, and we produce the reports on all the branches, wherein I can simply analyze the data on all these branches. So this is one of the scenario where we go for data warehousing solution. And let's look into the other scenario. Let's say I have one shopping supermarket which has a huge operational database. So in this scenario, I don't have multiple branches. I have only one branch at a single location, and now I want to see the report and I want to know how much revenue that I have generated today. So normally what happens in a shopping supermarket, whenever you purchase any item at the billing counter, so they'll use barcode detector, and using that they'll enter the information such as the quantity and the item that you purchased and the price. So all this information they are going to feed it into their machine or a system at the billing counter, and they'll generate the bill. So this is how it happens in shopping supermarket, wherein the data entry takes place at the billing counter and they generate the bill. Now, since I have a single OLTP system, OLTP is nothing but online transaction process, where we have a centralized database and the data entry takes place. Now at that, when the data entry is in progress, at that particular time I want to see the report, I want to generate the report and see the output. As an executive, I am the owner of the company and I want to see how my business is running. So what is the issue in this, wherein I don't have multiple branches, I have a single database, but still I'm facing some issues. So what are all those issues? So this is how the existing system that I have, wherein data entry operators are continuously entering the data into operational database, which is known as OLTP. And now the management at the same time wants to check the report or run the report. So what happens here? If the system is busy in getting the records into it, at the same time when you try to run the report, you might face two different types of problems. One is the report might take much time to run because the system is busy in getting the records into it, or when you're inserting the record, sometimes the table get locked, wherein you won't be able to read the content until unless you finish the data entry. So any one of the problem that you might face wherein you can't run the report when the data entry is taking place on your operational database, then how do we resolve this issue? So we need to ask data entry people stop entering while you're viewing the report, which is going to affect the business. If you start entering the data, so a customer is not going to wait for a long time at the billing counter, right? So which is going to affect your business. So what is the solution that you're going to apply for this situation? Again, we go for data warehousing, and in this data warehousing, in this solution, we are going to extract the data needed for analysis from operational database and store it in a warehouse. And this warehouse, we are going to regularly extract the information and load it into a data warehouse. So this is ongoing process at a regular interval of time, wherein every day we get new records into our operational database, right? And when do we extract the information and load it into warehouse? So as soon as we close the business, maybe at the midnight, 12 o'clock or 1 o'clock, we set some time. And as soon as you set that time in ETL tools, so our job is going to invoke based on the time that we provided, and then it starts reading the new record that you have got in your operational database, and it's going to load that information into a data warehouse, so that the next day when you want or the management wants to run the report, they can use this warehouse as a source for their report, and then they can run the report and see the data. So this process happens regularly, and wherein in operational database we get the current data, and the next day so based on the schedule that we run, it extracts the newly inserted records into warehouse, and the management is ready to generate the reports on top of that and able to analyze the data. So that's why we go for data warehousing. And we have another scenario wherein a cakes and cookies small company, and wherein the president of that company wants his company should grow. So he's generating, the company is generating very less revenue, and he wants to analyze what is the cause. And he needs the information so that he can make correct decisions. So he just want to know what is the reason behind this. So in order to know that, he should have the sales information. So which item has more demand and which item has less demand, and based on that, what he can do to improve the business. So all this analysis can be done only when he can analyze the existing or historical data that he has for the company. So in this scenario, so we extract the information, and not only extracting the data as it is from the source, we also cleanse the data. If we have any scrap data or unwanted data, we are not going to load that information into warehouse. So to improve the quality of a data before loading into the warehouse, that's what we do in ETL, and perform the data cleansing and transformation before loading the data. And use query analysis tools to support ad hoc queries. So any ad hoc request that you want at runtime in your reporting tool, you can make use of those analysis tools, and you can run the report and get the output. So what kind of a scrap data it means? So sometimes it is unuseful data, but still what happens, for example, let's say in my source system I have a location column, and in that location column, while the data entry people, sometimes they might enter New York, and sometimes they might enter NY. So both belong to the same city, but while querying my data, I might put a filter on New York or NY, which is going to retrieve less number of records than what I expect, because I have two different names for a single city. So in that situation, it will be difficult for me to analyze the data. You might think that the data is missing, But the reason here is the data what we have loaded in our data warehouse is the quality of the data is not correct or is not good. So in that scenario, so we need to cleanse the data and convert into a single format, either in the form of a New York or in the form of an abbreviation NY, a single value for each city. So all these operations will be done at ETL2 level before we load the data into our data warehouse. And once you have the data, now I can analyze my data on top of data warehouse by querying the data and generate the reports and see. And with that, I can make a decision whether I need to go for an expansion of my company or an improvement. If I'm generating more revenue, I go for expansion. If it is generating less revenue, I need to look into something. I need to make some decision. How do I improve my sales? So with all these scenarios, what is a data warehouse? A data warehouse is nothing but a subject-oriented, integrated, time-variant, non-volatile collection of data in support of management's decision-making process. So what does it mean by subject-oriented? So subject-oriented is nothing but we know that we are extracting the information from the source system to the target data warehouse. So here, when we extract the information, we don't extract as it is. We choose what are all the information that we want, and we store in a different manner in our data warehouse when you compare with source operational database. So the way how we store the information in operational database, which is OLTP system, is different the way how we store it in data warehouse, which is OLAP system, online analytical process. But ultimately the data is same, but the way how we store is different. So subject oriented means data warehouse is organized around subjects such as sales, product, customer. So it focuses on modeling and analysis of data for decision makers. So exclude the data not useful in decision support process. For example, if I want to concentrate on sales information, then if I have all the sales information together at a single place, it will be easier for me to analyze this. But if you store the information all together, wherein you have sales, product, customer together, it might be difficult for you to analyze the data. So when we store the information, we store it in the form of a subject-oriented manner. So let's take an example of a banking sector here. And here in this banking sector, on the left-hand side, you can see operational. On the right-hand side, you have data warehouse. Operational is nothing but OLTP system database, and data warehouse, which is OLAP system database. So under operational in a banking sector, we have multiple subjects or multiple departments, as in loans department, savings account department, bank card or credit card department, and trust. So in each department you have some applications where the data entry takes place. Suppose if you open an account, so it's going to be under savings department, and they have their own application, and they are going to feed the information based on the application that you fill, and they are going to feed it into their system, and they'll just click on submit. So that information will be loaded into the backend database. So all these applications that you have under operational databases, these operational database is application oriented, which means based on the application we build database. That's why all OLTP systems are application oriented databases. Now the same information, when we load that into a data warehouse, how do we store that information? In the form of subject oriented. What does it mean by subject oriented? For example, if you look into data warehouse, I have sub databases like customer database, vendor. We can also call this subject oriented databases as data marts. So customer, vendor, product, activity. These are all subject oriented. So customer means a customer might be from loans department, savings account, credit card, or trust. In all the departments you have customers. But wherein when we store that, when we extract that information using ETL tool and load it into our data warehouse, we load it in the form of subject oriented manner. So customer means he might be from any of these departments. In the same way, vendor and product. So that's why data warehouse is also known as subject oriented. And then integration. So we have already seen the first scenario wherein extracting the information from multiple heterogeneous databases and loading into a centralized database, single site. That's why it is known as integrated. And then time variant. So time variant, which means when we load the information into our data warehouse, so this data warehouse is going to contain all the historical information. So for example, if you want to retrieve maybe 5 years ago data or 10 years ago data, you will be able to get it from data warehouse. So we store all the history in data warehouse. That's why it is known as time variant. And non-volatile. So as soon as we extract the information from OLTP system and load it into data warehouse, we will never update any record in our warehouse. For example, I have a source OLTP system on HR department. And in that department, let's say I have a specific employee who has been working for almost 5 years and now he got promoted, and now let's say he was working in New York and now he got promoted and moved into a new location, Chicago. So now what do we do in our HR database? So we have an application wherein we search for a specific employee who got promoted and we update the city information from New York to Chicago. So now as soon as you update it, now when you are analyzing the employee information, if you want to know at so and so date, so this specific employee, where is he located, you won't be able to get it from OLTP system. But the same updated record, when you load it into your warehouse, we'll be tracking that as two different records. So from this time to this time he was working in so and so place, and from this time to this time now he got promoted, now he is working in this location. So when we extract any information from a data warehouse or OLTP system, if we get any updated records from the source, we store them as a new records with a different timestamp in our warehouse. So warehouse always consists of history and we'll never update any record which got loaded into our data warehouse. That's why it is known as non-volatile. So that is about the definition of data warehouse, which is subject oriented, integrated, time variant, and non-volatile collection of data in support of management decision making process. So here are some of the differences between operational versus information system, which is OLTP versus OLAP. The features or characteristics which are under operational, it is for operational processing, and under information, it is for informational processing. And the orientation of the data is a transaction under OLTP system and analysis under information. Who are all the users who uses this operational? Clerk, DBA, database professionals. And who are all the users who use this OLAP system? Knowledge workers in the sense the people who runs the business. And the function, day-to-day operation will be stored in operational database, but For information or OLAP, it's based on a decision. You might load the information every day or once in a week or once in a month. So it will be based on a decision made by the knowledge workers or business users. So the data will be current in operational, wherein it's an historical in information. And we get detailed and flat relational information from operational, but when we load that information into our OLAP system, we load it in a summarized format. Which means, as an example, as I said, every day you get new records in any supermarket if you purchase any information, any items. So they enter the information, and sometimes they'll also enter the customer information. But as a manager or a CEO of the company, I don't want all those detail level information. I just want to analyze the data, how much revenue that so and so specific branch has generated for me. And I'll be looking at high level data, how much revenue that I have generated last year for the full year, and how much revenue that I have generated till date in this year. I can compare it, but I'm not worried about who purchased it, how many items that he purchased it. I don't want that information. I want a summarized level information. So when we load this information, we pre-calculate all those summaries and we load that into a warehouse so that it will be easier for me to analyze on top of multiple dimensions, like I can see yearly sales information or monthly sales or quarterly sales. And coming to the database design changes when we compare with operational and information. So as we know, operational or OLTP systems are application oriented, wherein information or OLAP systems are subject oriented. So all these application oriented supports not only reading the data, it also supports inserting and updating the data in a backend database. So we normalize the database in OLTP, but wherein in OLAP we don't insert or update any database. So that those operations will be taken care of ETL tools, but what we just do is reading the content and analyzing the data. That's it. So that's why OLAP is always in denormalized format. So this normalized and denormalized is the steps that we follow while building a database. It's completely related to DBA, the normalizations. And coming to unit of work, it's short, simple, and transaction per record in OLTP, but it's a complex query and information system. And then access, read or write access. As I said, you can not only reading in OLTP system, you can also update or insert the records. But wherein in information, mostly read, we don't update any records. ETL jobs are going to take care of that. And a focus will be given to data in OLTP system, but the focus will be given to the information that you get in OLAP system. The number of records that you access in OLTP system is tens or thousands, but wherein in OLAP it's millions of records because we store history. The number of users might be thousands in operational, but wherein in information only hundreds, because informational or OLAP system will be accessed by business users, not by the customers, right? And even the database size will be more in OLAP when you compare with OLTP because we store history. And the priority will be given to high performance and high availability for OLTP system because we use this OLTP system to run the business. And the priority will be given to the flexibility of analysis on OLAP because I'm not entering any information, I'm just reading it. So while reading it, I might want to compare with multiple dimensions. So the flexibility is given high priority for OLAP, but wherein for OLTP, performance is given high priority. The metrics is transaction throughput and here query throughput. Same thing as priority and metric, both are similarly defined here. So these are all some of the differences between OLTP versus OLAP or operational versus information systems. Now with all these definitions and the differences, This is how the data warehousing architecture looks like. Wherein in this data warehousing architecture, we have all the source systems which are OLTP systems. It might be databases or applications or legacy systems or flat files. And then we have target database, which is, we also call it as data warehouse. And then we have reporting tools to analyze the data that we have in this warehouse database. All together, we call this as data warehousing solution. And remember, data warehouse is not a tool, it's a collection of tools. We can call this data warehousing as a solution or as a package that consists of all these tools in it. So any organization, they are going to have only this OLTP system, and they come to you asking for, they want to analyze the data and they want so and so reports. So to get that, we need to perform all these operations wherein from the source, we closely analyze the source systems and the analysis what you want, and we extract only that information by using ETL tools into our data warehouse, and we store them in the form of data marts, which is subject oriented, and we use this databases as a source for our reporting tools, and we generate the reports. This is the complete life cycle of data warehousing architecture, and this data warehousing architecture will be built by our own based on the management decision. So what are all the tools that are involved? Source databases, target database, ETL tools, and reporting tools. So now in the market, we have a lot of BI related tools, business intelligence tools. Let's take an example of SAP. The source OLTP systems are SAP ERP systems, and the target is SAP BW with ETL, and the reporting tool is SAP Business Objects. So this is a complete package belongs to SAP. In the same manner, let's take an example of Microsoft. Microsoft has a source system which is SQL Server database, ETL tool which is MSBI, and then we have target database again, SQL Server database, and then for the reporting we have SSRS, SQL Server reporting. So now each and every company has their own data warehousing tools, and we can build data warehousing solution by making use of those tools. So that is about data warehousing, and we are at the end of the life cycle of data warehouse, which is known as reporting. As soon as you get the data into warehouse, then only you can start generating reports on top of that. So let's see how the data warehouse database looks like, and what are all that are involved in database, and how do we store the information in data warehouse database. So data warehouse server almost always a relational DBMS, rarely flat files. So it's, as I said, it is again a database which is a relational DBMS. And then OLAP servers. So here OLAP servers are nothing but we normally store the information in the form of two-dimensional in normal databases, right? RDBMS, wherein we have rows and columns. But wherein in OLAP, we store the information in the form of a cube. And we use that cube as a source, and we, by using client tools, we connect to that cube and we generate the reports. So what does it mean by multidimensional, and how is it different from OLTP system? Let's see. So data warehouse schemas, there are some predefined schemas, standard predefined schemas that are available in data warehouse. Those are all star schema, fact constellation schema, or extended star schema. We can also call that as extended star schema or snowflake schema. So these are all the standard predefined schemas that are available in data warehouse. And this is how we store the information in data warehouse. So what does it mean by star schema? A star schema is nothing but single large and central fact table and one table for each dimension. So every fact points to all the attributes of dimensions, and it does not capture hierarchies directly. So let's say in OLTP system I have customer information. So a customer information might be stored in multiple tables. So that is what normalization means. Let's say I have customer name and address information. We store it in address table, and I have a customer name and what is the quantity that he purchased and how much price for each and every quantity, and from which branch. All this information stored in another table. So like that, we split the information into multiple tables to avoid the redundancy or duplicates, and we normalize them, and we relate those tables with primary key and foreign key relationship. So this is how it used to be in our OLTP system. And that data, we need to extract it and load it into our warehouse. How do we store that information? In data warehouse, we split the information in the form of facts and dimensions. Facts are nothing but which deals with measures. Measures are nothing but the columns on which you can apply aggregate functions like sum, count, and so on. In real time, sales revenue is a measure wherein we can apply sum on that, and quantity sold is a measure. So like that, all the columns on which we can apply aggregate functions, we call them as fact information. And we have some other columns which defines those measures, like customer who purchased it, item name what he purchased it. All this information comes under dimensions. So dimensions are nothing but which describes the transactions, and facts are nothing but the information which consists of an aggregated values. So we divide them into two, and we load that information in a separate tables like this, wherein fact table consists of units and price and the foreign keys of all dimension table primary keys. So here I have store dimension, which consists of all store related information, time dimension, which consists of all time related information, and product dimension, which consists of all product name related information. So all these dimensions are linked to a single fact table, and this fact table consists of units and price, and then the foreign keys to relate it to store dimension, time dimension, and product dimension. This is known as star schema. Fact table in the middle, surrounded by dimensions, is known as star schema. And what is the use of this schema? Which is going to build a cube at runtime. With this relation between the tables, overall together, this forms a star schema, and that schema will help you to analyze the data and will provide you multi-dimensional analysis. For example, if you want yearly price information or sales information, we drag this year from time dimension and we drag this price, you get yearly sales. You want product wise price information, you drag this product description and price, you get product wise price information. You want store wise sales information, drag this store and the price, which gives you the store wise information. That is known as multi-dimensional. Same measure with combination of multiple dimensions. So this is mostly used schema in all data warehouse, which is star schema, which is very fast and easy to analyze. And coming to Snowflake, it's same as star schema, but wherein the dimension tables are normalized. For example, here I have a fact table surrounded by dimensions, but here one of the dimension is split into two wherein city location information is stored in a separate dimension called city dimension, and then you have a store dimension. So this split takes place. This is known as normalization. If the dimension tables are normalized, then it is known as snowflake. And what is fact constellation? Same as star schema, but wherein if you have more than one fact table in the schema. So here I have two fact tables surrounded by dimensions. Then it is known as fact constellation, or it can also be called as extended star schema. So these are all the predefined schemas that we build in warehouse, and we store the information in this format, which supports multi-dimensional analysis. So building data warehouse. So how do we build this data warehouse and how do we extract it? So let's see. So we have some case studies wherein we have one foods and beverages company, a new company which produces dairy, bread and meat products with production unit located at Chicago. Now their products are sold in New York, Texas and Colorado region of USA. So they have sales units at New York, Austin and Denver. Now the president of that company wants sales information. How do we generate the solution for that? So we extract all the sales information. The report should looks like this: the number of units sold and the number of units sold over time. So this type of analysis what the management wants to see. So to get that type of information, we store the information and the number of items sold for each product with time. So these are all multi-dimensional analysis. So the need based on a product, based on a time, and also based on location. So this type of multi-dimensional analysis what they want to do. So as a solution, what we do here in this scenario is we collect all measures and dimensions information. So in this scenario, the measures are units sold and amount, and dimensions are product, time and region. And this is the fact table. This is how it's going to look like, wherein a fact consists of all the foreign keys of the dimension tables. Let's say suppose a city, product and month. So we don't store as it is, wherein we are going to have a foreign keys and we are going to have a separate dimension tables for all these three entities. So like this. So this is the fact table, and then we also have a product dimension table and then region dimension table like this. And from this information, so this is how we build a warehouse, which is a star schema or a snowflake schema here, wherein the product is normalized here. So sales fact table surrounded by dimensions. So we extract all this time information, product information, region information from the source, and we load it. And then we relate these tables like this, and we build the reports. So this is how the OLAP takes place. And this is how we store the information in data warehouse. And we can perform multi-dimensional analysis. And it also supports drill down and drill up functionality, wherein let's say you have the data on yearly sales information. I want to drill down to quarterly in that year. And again from that quarter I want to drill down to month level. You can do those operations as well when you have the data stored in the form of OLAP. So that is about OLAP operations that you can perform. We can perform drill down and drill up, and at the same time pivoting. So converting columns into rows or rows into columns. All this analysis can be done at runtime. So OLAP server is a high capacity multi-user data manipulation engine specially designed to support and operate on multi-dimensional data structure. And we have different OLAP servers like MOLAP, ROLAP or HOLAP. So multi OLAP or relational OLAP or hybrid OLAP. which is combination of MOLAP and OLAP. So what are all these different servers? So all are OLAP servers, but the way how we generate these OLAPs or the location of this OLAP is different in each and every type of OLAP server. So the process is same, but the storage on or generation is different for each and every OLAP servers, which is not so important as a report developer, so that will be taken care by ETL developers. So this is how we use that OLAP as a source, and using a reporting tool we connect to that and generate the reports. The data warehousing solution includes wherein we have flat files we extract into data warehouse. On top of this relational database we build a cube at runtime, and on top of this cube we analyze the data in a presentation layer, which is a reporting layer. So the need for data warehousing: industry has huge amount of operational data. Knowledge workers wants to turn this data into useful information. And this information is used by them to support strategic decision making. That's the reason we go for data warehousing solution. And it is a platform for consolidated historical data for analysis, and it stores data of good quality so that knowledge workers can make correct decisions. So from business perspective, it is latest marketing weapon, helps to keep customers by learning more about their needs. Valuable tool in today's competitive, fast evolving world. So we have data warehousing tools related to different companies. One is Microsoft, the other one is Oracle. And these are all the references link that you can go through to get more information about data warehouse. So with this, we are done with introduction to data warehousing, and in the next class we'll discuss about introduction to business objects reporting tools. Thank you. Welcome to Business Objects 4.0 training session. So today we'll be discussing about introduction to SAP Business Objects 4.0. So Business Objects has been acquired by SAP in the year 2007. And not only Business Objects, SAP also acquired another company called Outlook Soft, which is PPC, Business Planning and Consolidation. So SAP has acquired this business objects in order to improve the reporting options that we have in SAP BW solution, wherein this business objects will be replaced by BEX reporting tool in SAP BW environment. So what is business intelligence? So business intelligence is an iterative user-centered process that includes accessing and exploring information and analyzing this information. So we build business intelligence solution to analyze the data and to take the decision quickly based on the metrics that we build in the presentation layer, that is nothing but a reporting tool. So there are a lot of advantages or benefits using business intelligence solution. So a few of them are mentioned here, like identify and track key performance metrics, improve customer service, streamline the operations, and reduce the cost and anxiety over compliance, and so on. So business intelligence solution is mainly for analysis purpose. Based on the analysis report, you can quickly take decisions like improving the organization or taking any type of a decision that would improve the revenue in an organization. So there are two different tools, wherein from SAP we have SAP BI end-to-end model, and we have object solution, which is business objects that consists of reporting and an ETL tool. So in SAP BWN we have modeling, info objects, cubes, ODS and data marts, where we store the information. And SAP BW is a tool that consists of both reporting as well as ETL, wherein extraction, transformation, and loading takes place. And apart from that, we also have a reporting tool, as I said, PEX, Query Designer, or VAT. So these are all the reporting tools that we have in BW solution, and now which is being replaced by BobJ solution, wherein in business objects we have business objects reporting as well as an ETL tool which is known as business objects data integrator. So now this business objects data integrator is also one of the part of SAP BW, wherein if you want to extract the content from uh, other than SAP ERP sources, then we use BODI jobs and we call those jobs from BW in order to load the data into BW. So now SAP BW and BO merge together and we have an SAP BI solution with BW and BO together. So Business Objects Enterprise. So Business Objects Enterprise is a product wherein we have the server installation at a centralized location, a remote server, wherein all the developers develop multiple reports, and this enterprise is going to act like a centralized repository to share the information with the clients. So Business Objects Enterprise client applications by role. So here we have divided multiple applications based on a role, and we have 4 different roles in Business Objects. One is administrator, the other one is business user, data manager, and designer. And the tools which we use under each and every role are listed here. So we have designer and we have some reporting tools, and under data manager and we have some ETL and semantic layers, and administrator we have again multiple tools to administer the content of business objects, and then business user. So business user is basically the person who runs the business, who has a basic idea on the business, and he can generate standard reports on top of the data. Coming to the business user, so what are all the tools under the role business user? So that is InfoView, wherein in the latest version we call that as business objects launchpad, and then web intelligence, which is a reporting tool, web based, and web intelligence rich client, which is a client based tool, live office, query as a web service, Voyager, dashboard builder, and performance manager. So these are all the tools used by business users. And let's look into each and every tool. Business Objects Enterprise InfoView, which is, as I said, a web-based application or an interface which is used by an end user to access the content of Business Objects centralized server. So it's a web-based application. You just need to log into that application and view the output of the reports. And then Web Intelligence, which is a web-based tool that provides query, reporting, and analysis functionality for relational data sources in single web-based product. So this is a reporting tool which doesn't require any installation on our developer machine, wherein you can directly connect to the server through web by running a URL and provide user ID and password. As soon as you connect, you should be able to generate the reports at runtime using Web Intelligence. And we have Webby Rich Client, which is same as Web Intelligence, but wherein this is a client-based tool wherein you can develop the report in an offline mode, and then you can publish them in Business Objects Server. And we have Live Office, which is an integration tool between Business Objects and Microsoft Office products, wherein if you want to place the data of Business Objects reports, it might be Web Intelligence or Crystal, you can place that information on top of an Excel sheet or a Word document. And not only that, you can get the live data at runtime by integrating business objects with MS Office using an integration kit, Live Office. This is same as like what we have in analysis edition tool for Microsoft Office in BW, wherein you can get the information from BW Cube on top of Excel sheet. So that is about Live Office. And then Query as a web service. So whatever the queries that we use to run on top of backend database in order to extract the data, so those queries you can publish as a web service so that it generates one WSDL URL, web service destination language, and you would be able to run that URL through browser. And as soon as you are authenticated, you will be able to get the data in the form of an XML. So you can call the data through web by generating web services, and you can generate your own web services in business objects using a client tool called Query as a Web Service. And then we have Voyager, which is again a web-based reporting tool, especially for cubes. So wherein Voyager is capable of connecting to the cubes directly, and you can analyze the data through them. And you can't connect to a relational database, you can connect to cubes using Voyager. That is the use of Voyager. And then Dashboard Builder, which is again a web-based tool to monitor key performance indicators and proactive alert managers via email and dashboards with information they need. So this Dashboard Builder is used to customize the way how it displays the content of business objects through BI Launchpad. And then we have Performance Manager, which consists of a standard graphs like bar graph or scorecards, which is used to analyze or track the metric via management dashboards. So this is in line with the Dashboard Builder, wherein we use this Performance Manager analytics to display on top of dashboards. So coming to the other role, which is designer. Under designer role, we deal with Crystal Reports, Web Intelligence, Dashboard Manager, Desktop Intelligence, and Excelsius. So Crystal Reports is also one of the Windows-based reporting tool like Webby Rich Client, but these Crystal Reports are especially for OLTP system. We also call this Crystal Report Designer as an operational reporting tool in order to generate the reports which can directly connect to a backend database and retrieve the data and displays on top of Crystal Reports. So this is also known as operational reporting tool or pixel perfect formatting. So we use Crystal Reports especially when we want to develop a complex formatting type of report or a financial report, because Crystal Reports support a lot of scripting language like C# and VB. And we also have Web Intelligence, as we discussed before, and then Dashboard Manager that we already discussed, and Desktop Intelligence, which is an outdated reporting tool, wherein in the latest version 4.0 we don't have desktop intelligence. So this Desktop Intelligence is also one of the reporting tool in business objects, but this has been replaced by the new tool, which is Webby Rich Client. So basically we used to have two reporting tools. One is Desktop Intelligence, which is client based, which needs an installation. The other one is Web Intelligence, which doesn't need any installation, zero installation, ad hoc reporting tool, but with different extensions. Now they have decided, why do they need to have different extension? Why can't we have a same extension of the report file so that they can edit the report both through web as well as on desktop? So that's the reason they have introduced Webby Rich Client, and now Desktop Intelligence it's a deprecated feature which is no more available in the latest version, that is in Business Object 4.0. So we use Webby Rich Client. And Excelsius, which is a dashboard designer, lightweight reporting tool, which always generates the output by using the source as an Excel spreadsheet, and we can generate flash files using this Excelsius dashboard. So these Excelsius reporting or designer uses less number of records. You can't generate any report more than maybe 1 million or 1 lakh, because maximum number of records that you can use on this Excelsius designer is 1 lakh. Even 1 lakh is more, but this is known as lightweight reporting tool. Normally we use this Excelsius designer to generate graphs, especially which displays high level information like yearly sales or quarterly sales, plotting on the top of a graph. And then central management console administrator. So this CMC is also a web-based application, same as InfoView or BI Launchpad, but this application has been used only by administrator who is going to administer the content of business objects, like creating users and user groups, providing security rights on multiple applications, or security rights on reports that we published in business objects. So all the content management of the centralized business object server will be taken care through this web application by the administrator, that is nothing but central management console. And we have the other role, which is data manager. Under data manager, we have universe designer, business view manager, and data services. So this is the role where we exactly deal with the backend database and the data. So far we have seen all the roles, which is a presentation layer, how we format and how we display the data to the client. But this is the layer where we actually deal with the backend database in order to generate multiple reports. So under this role, we have universe designer, business view manager, and data services. So universe designer is nothing but a semantic layer which lies in between the reporting tool web intelligence and the backend database. For example, you want to generate a report on top of HR module. We have HR related table in the backend database, let's say in a SQL Server database, and I want to pull that data on my report. How do we pull that? First of all, we need to create a model. That model is nothing but semantic layer. In this universe designer semantic layer, we provide the connectivity information to the backend database. So once we connect to the backend database, then we choose what are all the tables that are required to generate or to develop your report. If I say HR related information, let's say I want to know all the employees and their salaries and the contact information. So to get this information from the HR module, I might just need 3 tables. So pull those tables, add that structure of the tables in this universe designer, and define the relationship between the tables, and then publish that universe in business object server. Now I'll make use of that universe designer when we generate a report and we connect to that universe designer, wherein that designer will automatically connect to the backend database connection and it generates the output for you. So why can't we directly connect to the backend database and pull the data? Why do we need to connect to universe designer? So there are a lot of advantages when you go for universe designer, especially when connecting to relational type of database, not an OLAP databases, but relational type of connectivity, wherein at runtime we generate the microcube using this metadata management tool, which is known as universe designer. So something like views that we create in a database, collecting all the tables and defining the relationship between the tables, and once you run the view, it displays all the data what you want. In the same manner, we are collecting all the tables in Universe Designer and defining the relationship between them. And as soon as you run the report, so based on the relationship that you provide, it's going to generate the query automatically, and it runs on top of a backend database and it retrieves the data. So we'll look into it more detail when we discuss about Universe Designer. And then we have Business View Manager, which is also a semantic layer, especially for Crystal reports. So Crystal reports is a reporting tool which is not originally from business objects. Before the acquisition of business objects into SAP, even business objects have acquired other companies like Seagate Crystal reports. So Seagate is the company who developed Crystal reporting tool. Now business objects acquired Seagate Crystal reports. So now Crystal and Crystal Excelsius, both the tools merged together into business objects after the acquisition. So now when it was with Seagate, even Crystal reports also follows the same process wherein it has a designer reporting tool, and in order to connect to the backend database, we have two options. One is through semantic layer, or without semantic layer, you can directly connect to the backend database. So that semantic layer is nothing but Business View Manager, which is especially for Crystal reports. Now coming to data services, this is not a reporting tool, this is an ETL tool wherein we use this tool in order to extract the content from OLTP system into OLAP system, business objects, data services. So that is under the role data manager. And let's look into the architecture of business objects. So before we move on to business objects architecture, so let's have a look how all these tools are installed and how it looks like in a Windows Server machine. So I'm going to open a server where I have the installation, and here if you look into this server machine, I have the installation. If you go to program files, here you'll be able to see business objects 4.0, and this business objects 4.0 comes with two types of installation. One is server based business object server installation. The other one is client installation, business objects client installation. So we have two types of tools: server tools, client tools. So server tool is, so all the server tools will be installed in a centralized location wherein multiple developers will be accessing that server through network. And remember, this business object server tools are 64-bit machine supported software. You can't install this on 32-bit operating system. So under business object 4.0, we have all the business objects platform, and these are all server related tools. And in order to see the content of business objects, what do you have inside business object server? So we have a BI launchpad, which we call it as info view in the old version, but in the latest version we call this as BI launchpad. As soon as you click on this, it opens that URL in a browser, and this is the URL which we are using, and that URL consists of the server name, port number, BOE/BI. So this is the standard URL, and the server name changes from one organization to the other organization. Here I just mentioned localhost because the system where I have installed is itself. That's why I mentioned localhost. So normally here they use the IP address of the server where they have installed, or the name of the system where they have installed. And as soon as you run that URL, it prompts you to enter user ID and password to connect to the business object server to see the content what you have. So I'm going to enter user ID and password to connect, and I'm going to log in as an administrator. And now as soon as I log in, I'll be able to see the content of business object server. So this is a quick view wherein you will be able to see the history of past reports, whatever that you have opened before, and you will be able to see the documents here by clicking on documents and browse through the folders. Click on folders. Now you'll be able to see the list of folders wherein in each and every folder you have different types of reports developed, and they are categorized into multiple folders. So if you want to look some sample reports of web intelligence, click on that. You'll be able to see the list of web reports, and if you want to view the output, just double click on any one of the report. It displays the output. So this is the output of web reporting tool wherein it has multiple tabs and you're displaying all the data. And at any point of time, if you want to refresh and get the latest data what you have in your warehouse, here is the place where you have a refresh button in order to refresh your report. So in the same manner, not only web intelligence, you also have sample crystal reports published, and you also have sample dashboards published here. So this business objects enterprise is going to act like a centralized server which is going to maintain multiple reports as a storage location, wherein you can compare this with Microsoft SharePoint software. So what is Microsoft SharePoint? We use Microsoft SharePoint in order to share the documents from one employee to the other employee in an organization. So here we can make use of this Microsoft SharePoint. I mean, in the same manner, we can make use of this business object server in order to share multiple reports that we develop with our client. so that client can log into this machine and he can browse through the multiple folders and he can open any report that he wants and he can see the output. So how we are able to run these reports from business object server? So through web, in order to run this report, you need to have the designer installed on your machine. But through web, how you are able to run these reports? Because we install the business objects enterprise, this enterprise consists of servers, related servers installed in this machine. And in order to see those related servers, you need to go to programs and the installation. And here under server tools, we have a client related tool which is known as central configuration manager. And this is the central configuration manager where we'll be able to see the list of servers which are responsible to enable the services related to each and every reporting tool that we run in business objects. So the architecture of business objects. Business objects architecture is of a 5-layered architecture. So the one which we are looking at is logical architecture that shows from the front end tools. What are all the tools that we interact with in business objects, wherein we have data repository, wherein we connect to multiple databases using data access layer like universe designer and business views, and we create the schemas and we define the relationship between the tables in this data access layer. And once you create these semantic layers, then by making use of these layers, we start generating reports from the end user layer. See, web-based and desktop client, two types of applications that we have. So in between your database and the reporting tools, we have multiple servers that are running on business objects server machine, wherein you won't be able to see this layer, which is business objects enterprise infrastructure processing tier. All these requests which we provide from this web-based application or desktop client applications will be passed through these layers and will be sent to the backend data access layer, and it connects to the database and it retrieves the data and then it displays here. So we have multiple layers. From the right hand side corner towards left, the process will be taken care, wherein from the client based application we provide the request and it will be sent through the web server, and web server will send to the application server. Under application server, based on the request given by, it might be a crystal reports or web intelligence. So based on the type of a report, it will be send that request to the corresponding processing tier servers, and from the processing tiers it invokes the semantic layer, and this semantic layer opens the connection of a backend database and runs the SQL, and it retrieves the data and it displays the data on top of this web-based or desktop-based applications. So this is a logical architecture of business objects enterprise, how the process flows. Now physical architecture is something like this, wherein we have multiple servers, and this is how the enterprise framework looks like. So this is an overview of architecture, how it looks like, and how it processes the request, and let's have look into each and every layer that we have in this business objects architecture. So basically, business objects architecture is a 5-layered architecture that consists of client tier, application tier, intelligence tier, processing tier, and data tier. These are all the 5 layers that we have. So what is the first layer? Client tier. A client tier is nothing but an interface that is used in order to connect to the business object server. Like we have seen desktop intelligence or web intelligence, crystal reports. These are all the client-based tools, which we use them as an interface and we connect to the business object server, and then we start generating the reports. So under client here we have two types of applications: web-based applications or packaged or desktop based applications. Under web based, we have InfoView or central management console. We've already seen InfoView is nothing but BI Launchpad, and central management configuration, which is CMC, used by administrator to manage the content of business object server. And other than that, we also have packaged applications like central configuration manager, as we have seen in our how to start or stop the server, list of servers, and then publishing wizard and import wizard. These are all the tools which are used in order to migrate the content from one server to the other server. So these are all the tools that we deal with under client tier, which is at the client level or the developer level. Now, using these tools, what we do as soon as we connect to these tools, we enter user ID and password in order to connect to the business object server. Now, that request will be sent to the next layer, which is application tier. So in this layer, a web server come into the picture. So wherein at the time of installing business objects, you have an option of choosing a web server, whether you want Java platform or .NET platform. Based on that, the URL changes. If it is Java platform, the URL for BI Launchpad will be with an extension .jsp. And if you want to use .NET platform, then the URL will be with .aspx. So while installing business object server, you can choose whether you want to go for Java platform or .NET or both. Any combination is possible here. But why do we need to choose web server while installing business objects? So this web server will give you an option of customizing the business objects application. For example, in your organization, you have .NET developers and you want to customize the InfoView or BI Launchpad page, wherein you want to have your own company logos to be added to that page, or you want to change some content, how you want to display when as soon as I log in into business object server. So that will be taken care by SDK, software development kit. So if you want to use Java, a Tomcat server will be enabled. And if you want to use .NET, IIS, Internet Information Services, need to be configured on your server machine. So this is the layer where you can customize the maybe 10 to 20% of PO application, and you need to decide which one that you want to go for. And once we pass that information through this application tier, and it moves that information into the next layer, that is intelligence tier. Under this layer, we have specific servers like central management server, cache server, file repository server, and event server. The first server which we have here is central management server, which is also known as heart of business objects server or enterprise. Because each and every request that you provide, once you log in here, will be captured by this central management server. So this central management server is going to act like a heart of business objects, wherein each and every request will be passed through this server. So as soon as you pass this information, user ID and password, so what happens in this layer? So the information, user ID and password, whatever that you have provided, it passes through central management server, and this central management server is going to check or validate whether the entered user ID and password is correct or not. How does it validate? Any information that we create or store, or anything that we change on top of business objects application, that will be stored in a backend centralized database that we call it as CMS repository. All this business objects application, business objects enterprise works on top of a database. Same as like we have applications in SAP ERP. SAP ERP is an application wherein anything that you perform on top of that application, you have a backend database which is going to act like a storage location. In the same manner, we have business objects enterprise application which has a backend database. So that database, you will get it at the time of installing business objects. You can choose where do you want to store all the business objects, enterprise application related information, in which database. You can choose that. If you don't have any database, business object server comes with a default database installation, that is SQL Server 2008 in 4.0. If you don't have any database, you can install database at runtime while installing business objects, because it's a packaged application that consists of both business objects as well as an inbuilt database. So now this central management server or CMS is responsible for maintaining a database of information about business objects enterprise system, and it checks whether the entered user ID and password is correct or not, and it responds back. If you are authenticated, you will be able to log in successfully. So that is what happens in business objects central management server under the intelligence tier layer. Now the next server that you have here is cache server. So as I said, as soon as you log in into business object server, you will be able to run any report, right, on demand by simply double clicking on that. So you can run that report multiple times by clicking on refresh button. So what happens every time when you click on refresh, it has to hit the database and get the data and display the data. But to improve the performance, whenever you log in, a session will open, and for that session, you have a specific cache memory, virtual memory stored on top of your business object server. So that first time when you run the report, it hits the database and it gets the data. And before it gets the data on top of the report, it stores that data in a cache. Now at the same time, when you again click on the same refresh button, now this time, rather hitting the database, first it checks whether the requested information is available in cache memory or not. If it is available, without hitting the database, it gets the data from the cache memory. If it is not available, it again hits the database and it stores that information in cache, and then it displays on top of your report. That is how it works. So first time it might take some time to get the data, but from there onwards, it takes less time in order to retrieve the data, because so not always it's going to hit the database to get the data. And this cache memory will be cleared as soon as you log out from the machine or business object server. So that is about cache server. Now the other server what we have here is file repository server. So this file repository server is responsible for maintaining the content of business objects. As I said, as a report developer, we develop multiple reports and we publish them in a centralized business object server. So where exactly it's going to store that information? Is that in a backend CMS repository? No. It stores all the files that you publish in the installation directory of business object server machine. So let me go back to the machine where I have a business object server installation. So this is the machine, and now I'll go to the drive where I have business object server installed. Program files, business objects. Under business objects, go to SAP Business Objects Enterprise XI 4.0. Under this, we have file store, and this is the place wherein file repository server is going to maintain these two folders. One is input directory, the other one is output directory. And in the input directory, whatever the files that you publish, it's going to generate a key, a primary key, a unique key for each and every object that you publish in business object server. Object in the sense, it might be crystal reports, or it might be Webby report, Excelsius dashboard, anything. We call them as an object, and as soon as you publish, it generates a unique number for that in order to identify that in business object server, and it stores that, and the physical location is this. So this is the physical location, and you will not be able to see the name of the report here because it will be in an encrypted format. But whatever the path that you have in order to access this report, this path will be stored in the CMS repository. So that whenever you double click on a report in BI Launchpad, that request will be sent to central management server, and central management server checks the repository. From the repository, it invokes that path where you have that report, and from that path, it opens that file in Business Objects BI Launchpad viewer. That's how we'll be able to see the output of a report through web. So this file repository server is responsible to maintain input and output directories that we have under file store. So all published reports will be under input directory. Then what is the use of output directory? So Business Objects Server not only used for running the reports on demand, you also have an option of scheduling those reports based on a time. So when you schedule those reports based on a time, so you have an option of setting up some time at so and so time, run the report, whatever the output that you get, export that output in the form of a PDF and add that PDF as an attachment to a mail ID and send that PDF as an attachment to a specific email address. All these settings that you can choose and set some time. Once the time reaches, it performs that operation and you're going to receive an email. This is an auto generation process. So we have two types of options in Business Objects. One is to run the reports on demand. The other one is schedule the reports based on a time. So whenever you schedule, it might be based on a specific time or on a recurring basis. So each and every report is going to contain history of instances when you schedule it and what is the output that you have got at that so and so time. All those instances will be stored in the output directory. We have two directories, input and output. Input, which is going to maintain all the published content, and output is going to maintain all the instances of each and every report when you schedule it. So if the file repository server is down, you won't be able to access any kind of a document in Business Objects Server. So that is about file repository server. I'm coming to the next server, event server. As I said, you have an option of scheduling the report based on based on a time. You also have an option of scheduling based on an event. You can create an event. If that event occurs, then only it schedules the report. For example, I want to check for a specific file in a specific directory. If that file exists in that directory, then only schedule my report. Otherwise, don't do that. Those type of events that you can create, so that even then you set some time, it checks for that event whether it got occurred or not. If that event is not available, then it's not going to start the schedule. So that is the job done by event server. So all these four different servers acts differently based on the request that you provide. That's why it is known as intelligence tier. It behaves intelligently based on the request given by the customer. And now moving on to the next layer, which is processing tier. Here is the place where exactly the processing of your request takes place. For example, I have double clicked on Webby report and I clicked on refresh button. Then what happens? That request will be sent to central management server, which is CMS. Now what is the job done by CMS? CMS checks whether this user has enough permissions to perform that operation in the CMS repository. If he has enough security level or permissions, then it sends that request to the corresponding processing tier level servers. Next step. Since you double clicked on Webby report, it has to send that request to Webby related servers. That job will also taken care by CMS. That's why it is known as heart of business objects. Any request that you give, it has to pass through CMS. Now CMS will send it to the next layer, which is processing tier. And here, in order to run Webby report on demand, Here we have a server called Web Intelligence Report Server. This is responsible to process your on-demand requests. For example, if you're scheduling a web report, then we have Web Intelligence Job Server, which is responsible to schedule the web report. So each and every type of a report has their own processing related servers. For example, Web Intelligence has Web Report Server and Job Server. At the same manner, Crystal Reports has Crystal Report Server and Job Server. Desktop Intelligence, same report server or job server. Each and every reporting tool have job server and report server. All the report servers are for on-demand requests, and all the job servers are for scheduling purpose, scheduling requests. Now, other than those two types of servers, what else that we have? We have destination job server. As I said, while scheduling, we also choose destination. So to configure those destinations, we use this destination job server. It might be a shared location that you want to send that output, or an email ID of the other person you want to send the output, or FTP location. All that destinations will be configured, and that service will be enabled by destination job server. And then we have connection server. As soon as we run any report on demand, it has to open the backend database connection. That will be taken care by this connection server. So normally when you run a Crystal report, what happens? For example, you double clicked on a Crystal report. First, that request will be sent to CMS. It checks whether he has enough rights. Okay, yes, he has it. Now, that CMS will send the request back to processing server, which is report application server. Crystal report application server. Now, this Crystal report application server executes that report and it checks whether the requested information is available in cache server or not. Let's say you don't have any cache memory there. So now cache server will send, since it doesn't consist of any information, it sends that request back to connection server. Now this connection server is going to open the backend database connection and execute the SQL, gets the data in the form of rows and columns. Now that data will be sent to this page server. Now what does the job done by this page server? Whatever the data that you have in the form of rows and columns, it converts that information in the form of encrypted page format .eps, which means you have the data in the form of rows and columns. Now it converts into pages because you are viewing that output in a report. Not only converting into pages, it also compresses the size .epf, and those EPF files will be sent to cache memory, and it stores that information in cache, and it sends the request back to CMS, and CMS displays the output through viewer. So this is how it processes the request into these multiple layers in the background. And this information is very important for an administrator in order to troubleshoot any type of issues that you face while running any report through BI Launchpad. So that is about processing tier. The last layer that we have is a data tier, to which database that you are connecting to in your report. You might be connecting to a flat file or SAP BW or SQL or relational connection, anything. So we have 5 different layers: client tier, application tier, intelligence tier, processing tier, and data tier. So this is about the architecture of business objects and how it accepts the request and how it processes the request in business objects server. So the process is same even in the latest version, but you have more related servers have been added, new servers have been added, but the layers are same. So this is the latest version, logical architecture that we have, and what are all the list of servers that we have under server intelligence agent CR node. We have central management server, and we have same connection servers, input file repository servers, crystal related servers, and we also have another application called Explorer, Dashboard, Web Intelligence, and so on. So that is about business objects, enterprise architecture. Thanks for joining the session.